Welcome to How to Make a Real-Time Strategy Game, Part 3. Part 1, we made a power grid. Part 2, we made a truck logistical system. This video is all about making robots, having them aggro, and then blowing them up. Robots can now be placed on the map and do a random walk. They do not have any collision detection. A new class RTS mob inherits from RTS model and is going to contain all of the robot code. The random walk code is simple. Have a timer. When it is reached, pick a new velocity and reset the timer. Update the position every frame with a velocity. There are now laser towers. They can aim at robots and blow them up. The towers use the A-star grid to find any mob in its area. It then fires at it, displaying the laser and subtracting hit points from the robot. The find mob function uses a simple grid search to see if any robots are in the grid. If the ID in the grid is -1, then it is empty. If it is a model, we can get the reference to it and then determine if it is a mob. When the robot has 0 hit points, it explodes using particle effects. These effects are simple to add to a Godot game. The explosion has smoke, debris, and fire. How is this made? The first step is to make a new GPU particle 3D node. You have to give the node some material. There are many pre-made shapes to pick from. Make the process material, which automatically has gravity. Remove the gravity and then give it a spawning velocity and a spread. Now it looks way more interesting. Let's switch it to spheres to make it look better. There isn't a point to having this much detail, since it can't be seen anyway from the distance. Having more detail will tax the GPU, especially slower ones. It is possible to change many things using the time curve. First, let's change the scale given time. Let's add some color by going to display and making an initial gradient. Before the color draws, a material needs to be created and it needs to be set to use as albedo. And there it is. We can also add a ramp in time. Sometimes it works well with initial, sometimes it does not. And we could finally add some alpha or transparency to the particles. Before it works, we need to enable it in the material. And let's adjust the curve a bit. There are many other options and effects possible. There is now some basic collision detection. The robots cannot go to a space which is currently occupied. A few lines of code are added to the move routine to do this check. There is now a harvester to gather resources. Not much progress has been made the last few days, just some minor code fixes, particularly with the tow truck towing larger vehicles. Often with game development, it takes a while to come up with ideas. Being stuck for a few days is not unusual and will happen several times during this game's development. There is now a laser tank that can fire at robots. The laser code was taken from the turret and put into its own class. The laser works by having a rectangle, being the laser, and particles for both the beam and the end effect. The laser size is adjusted given the distance to the robots, and the particle timing is also adjusted given the distance. I had the idea of having the robots drop resources when destroyed. The harvester is then used to collect these resources and then can drop them off at the silo. As it turns out, this does not work that well with an RTS, since it's more of take an area to get resources and not really a loot crawler. The better design that is implemented later is that bases, when exploding, when all their guards have been destroyed, create drops, or there's nearby treasure chests that can be collected when the guards are no longer there. The weak code is particularly bad, as each one is its own mesh. This was before I knew how to use multi-meshes. There is now an artillery tank. I realized it made sense to reuse the same base model as the laser tank. The code is not that good yet. This is before I have an effects cache, so each model calls its own effects. This also means there isn't any caching, so the first time something explodes, there is a delay. Each time there is an explosion, it is instantiated. With the cache, all the explosions have already been created, so they just need to be turned on. The way shells are fired is using a key press, which tells the HUD to send a message to any object that is selected to fire something. The artillery tank overrides this function to do this. A robot generator is made that spawns robots and keeps spawning them to a maximum count. It also generates replacements when a robot is destroyed. An interesting note is how this code works. The generator does not get a signal when a robot is destroyed. Instead, it always runs a spawning timer, and the first thing it does is it checks if the robots in its list still exist. If one doesn't, it is removed, lowering the total robot count. If the total count is less than the maximum, a new robot is created. There's a helper function in GP helper from code new RTS item, so the instantiation code does not need to be copied here. However, it does use a lookup table value. Later, when inventory is created, it is changed to enumeration instead. The last few days were spent thinking about game mechanics. At this point, most of the ideas are wrong, but one good idea was found. Instead of having melee units that draw aggro, that is, the robots attack them, units will be summoned that summon aggro. The decoy truck is added, and the mob can aggro to it. Also, the mob resolves collisions now, meaning they bounce off each other. I was not using flocking yet, so I manually coded in the ability to surround objects, which at this point is blocky, but it is a start. The decoy truck is an RTS action model with an aggro value. The mob has two aggro states. When it has a direct line to the aggro, that is state aggro. If it has to pivot around to get this direct line, it is aggro divert. Aggro divert tries to pivot the robot either left or right, picking the side that does not have further collisions. This approach is not found to be correct, but I did spend enough time to get it to work properly. There is a famous GDC talk on how StarCraft 2 was made. StarCraft 2 uses flocking, and after watching that video, I decided to implement parts of it. It does not work yet, though. The talk is well worth watching to anyone that wants to develop an RTS. The robots now get an impulse based on what robots are nearby by checking the grid. Any robots within range of the current robot applies a spring force if they are in between the minimum and maximum distance. There is some improvement on how the robots move to smooth out when they surround an object. Most of the changes were just changing the force values rather than making new code. Code was added to divert around buildings. It doesn't quite work yet. The code is similar to the pivoting around other robots, except buildings are bounding boxes, so it is slightly different. Either the robot goes left or goes right, though. Aggro movement around buildings has been improved. We now have go-to state, so the robots can move as a group. The flocking is working quite well. There are still hang-ups around buildings, though. The go-to state finds a path, but it uses flocking to determine the robot's velocity. As you could see, the robot generator is smaller and makes way more robots. There has been incremental improvements in going around buildings, and the aggro overall is improved. The robots now have animation when attacking, and if you look at it, it looks a little like the current game. Now let's have some fun and blow up some robots. Let's start with artillery to see what it does. Yeah, that looks good. The artillery was improved so that the explosions take longer based on how far away the shell landing is from the robot's position. This month started slowly, mainly due to not really knowing what the next steps would be. After I focused on robot movement, I started to see some real progress. Unfortunately, if you watch the GGC video, The Making of StarCraft 2, it is obvious that something is wrong. However, it wasn't obvious what it was. When I started to look at performance, I made a change that led to the flocking working properly. But that's going to be for a later video. Thanks for watching.